want to look at this problem?
Yeah.
So, I have added a third equation. Okay, it does not change anything about the process. Same idea. So we first set up our matrix. We have 1, -1, 5 equals -6.
So, yeah.
You can switch rows if you want, but we do already have a 1 right here, so we wouldn't have to.
Or is that the one that get affected?
It's going to get changed as we go through it. So, first step, we need a 1 in row 1 column, and we already have it. Second step, we haven't had this before where there were other multiple rows, but we need all of those to be zeros, right? To get that, so I have to change row 2. All right, there's several options that we have, but let's just try to pick an option that would always work so we can kind of focus on that. So, yep. Row 2 is a +3, so this is how I'm going to write it. Row 2, I'm going to start with row 2. It's a +3, so we need to subtract 3. But we know we can't just subtract a number, right? It has to be multiplied by another row. So row 1 is the one that we have a 1 there. So it's going to be -3 times row 1.
Does it cool if we put -3 R1 plus R2?
Yep, that's the same thing. And I'm going to go ahead and do row 3 at the same time. So row 3, if I start at row 3, it's a +1, so I need to subtract row 1. Okay, I'm using row 1 for both of those because it's the one that has a 1 for the column. All right, so as we go through, we have 3 minus 3 times 1, so that's 0. 3 minus 3 times -1 is 6. -1 minus 3 times 5, -16. And 10 minus 3 times -6. Row 3 minus row 1. So 1 minus 1, 0. 3 minus -1.
4.
2 minus 5. 5 minus -6.
11.
All right. Column 1 is done. What do we need next? 1 in row 2, column 2. So, one option that will work every single time to get a 1, multiply by the reciprocal.
1/6 or 1/3?
1/6 because
Oh,
it's
shoot.
6.
Yep.
Were you looking at the previous?
No. I would never.
So row 1 and 3 are staying the same here. We're only changing that middle row. So 0 times 1/6. 6 times 1/6. -16 times 1/6. -8/3. And 28 times 1/6. They are helpful.
Gate 3, Mikey.
Okay. What do we need next?
0 in column 2.
Everything else has to be a 0.
I got 8 left.
To get those zeros, we are going to use row 2 because we just turned that into a 1. Okay, so row 1. If I start with row 1, it's a negative 1, so what do we have to do?
Plus 1.
Plus 1 of,
R2.
so row 1 plus row 2. Okay, for the third one, we start with row 3. It's a positive 4, so we need to subtract 4 of
R2.
row 2. Does everybody see how I'm getting those equations? So, second row is not changing here, but the other two are. Okay, this is where you can grab your calculator, you can write it out. So row 1 plus 1 of row 2. So 1 plus 0, still 1. Negative 1 plus 1 times 1 is 0. 5 plus 1 times negative 8 thirds.
7. Yeah, right.
Negative 6 plus 1 times 14 thirds.
Negative 4 thirds.
Now let's do the bottom row. So row 3 minus 4 times row 2. So 0 minus 0 is still 0. 4 minus 4 times 1, 0. Negative 3 minus 4 times negative 8 thirds. And 11 minus 4 times 14 thirds.
Negative 1
Alright, they're about to start disappearing. What do we need next? Okay, easiest way to get a 1?
3 20 circles.
Mm-hmm. So rows 1 and 2 are not changing. Bless you.
Person has been on one lately. Been out.
Allergies this time of year. 0 times 23 thirds is still 0. 23 over 3 times 3 over 23, that's a 1. And this would give me negative 1. Alright, we are one matrix away from our answer. What do we need now? We need the zeros in both of those. So let's start. Which row will I use to get those? Row 3. Okay. So row 1 equals row 1. It's a positive 7 thirds, so we will
Negative.
subtract 7 thirds of,
Row 3.
for the second one, row 2 equals, we start with row 2. It's a negative 8 thirds, so we will
Add
8 thirds of,
row 3.
so 1 minus 0 is still 1. 0 minus 0 is 0. 7 thirds minus 7 thirds,
0.
negative 4 thirds minus 7 thirds times negative 1. Second row. 0 plus 0 is 0. 1 plus 0 is 1. Negative 8/3 plus 8/3 is 0. 14/3 plus 8/3 times negative 1.
2.
So this says x equals 1, y equals 2, z equals negative 1. So we get 1, 2, negative 1 for our answer. So having that third equation added a couple matrices to our answer, but think about with elimination. When we added that third equation, it tripled the amount of work that we did, and that wasn't the case here. It added a little bit less. You know, if I would add a fourth equation, it would just add a couple more matrices, but it wouldn't add that much more work. Whereas elimination, it would add a lot more steps to it if you had 4 equations. All right, can we do another one of these together?
Yeah,
Sure, I guess.
Go.
Okay,
Fill the rest of my page.
I mean, you could say no, I guess,
No.
but
No.
you want to see
No.
problems.
No.
You just want to do it on your own? You want it for homework?
If we don't
How
have a
can we solve
variable,
it?
we add a 0 then.
Yes. So you'll notice that first equation does not have a z, so you have to put a 0.
So I already had a 0.
It
Great.
does.
That's fine.
We'll probably mess it up as we work through, but
Great.
looks
How
good
can
for
we
the
mess
moment.
up a 0?
If you add,
What do we need first? A 1 in row 1, column 1. There are 2 options for doing that. Tell me one.
flip it.
You could flip rows 1 and 2,
Or half.
or you could multiply row 1 by a half.
Yeah, let's do that.
Yeah. Either way, I mean, we're not going to get fractions, so it really doesn't matter at all. We can just do 1/2. You want row 1 equals 1/2 row 1. If you were going to flip the rows, you would just say row 1 equals row 2.
If we recognize and start writing it, do we have to write row 1?
No, so you could, if you recognize it from the beginning, just write it when you put it in the matrix, so the first one's first, and that's also okay.
Because we flipped it, would the variables be different?
No, because the variables are based off columns.
Okay.
So as long as you don't move numbers to different columns, it's still okay. All right, now what do we need? We do have a lot of ones. So we need some zeros. All right, so for row 2 equals row 2. It's a positive 1. Which row am I going to use to get these zeros? Yep, so you could just do row 2 minus row 1. Row 3, if we start with row 3, it is a positive 3, so we need to subtract 3 of row 1. So 1 minus 1,
No
0.
solution is consistent.
1 minus 1
Yes,
is
it is.
0.
Yeah,
1
0
minus 0 is 1.
Oh, you can flip it.
1 minus 3 is negative 2.
Someone's home.
So 3 minus 3 times 1. So 3 minus 3 is 0. 4 minus 3 times 1. So 4 minus 3. Negative 1 minus 0. And 13 minus 3 times 3. So 13 minus 9.
4.
Okay. No, it's almost a no solution. Not quite. All right, what do we need next?
0.
Or 2 equals our 3.
Yeah, let's just flip rows 2 and 3.
Row 3.
Yeah, row 3 equals row 2, or row 2 equals row 3, either way. We do already have one part of the solution, don't we? Alright, so we need a 1. We've got that. Everything else in the column needs to be 0, so that's really just the first one. So let's use row 2 to get that. So whoops, row 1 equals row 1 minus row 2. Well, no.
Row 1 minus.
You could not do row 2 minus row 1 because then your 1 would change to a negative.
Okay.
Alright, so 1 minus 0 is 1. 1 minus 1, 0. 0 minus negative 1 be 1. 3 minus 4, negative 1. And rows 2 and 3 stay the same. Okay, next we need a 1 in row 3, column 3, but we've got it. So we just need zeros. So we'll use row 3 to get those zeros. So for row 1 equals row 1. What do you need to do?
Yeah, subtract
You
row
got
3.
it.
And row 2, if you start with row 2, you need to
Add row 3.
so 1 minus 0, still 1. 0 minus 0, 0. 1 minus 1, 0. Negative 1 minus negative 2.
1.
Second row. 0 minus, or 0 plus 0. 0, 1 plus 0. Negative 1 plus 1. And 4 plus negative 2. So we get x equals 1, y equals 2, z equals negative 2.
Alright, you go for the next one.
Do we need another example? So your assignment is 4 questions. 2 of them have 2 equations and 2 have 3 equations, and you've got a lot of time right now to work on that.
Fun side.